Hello, my name is Yuri Khodlevsky. I'm a PhD student of software engineering at Zhytomyr Polytechnic State University, and today I am going to talk about simplified convolutional model for detecting anomalies in helicopters operation. Also, I would like to express my gratitude to organizers of this hackathon, and especially to Eric Behoifer, who provided the dataset and such an interesting problem to solve. And also, I would like to thank my supervisor, Tatiana Vakaluk, for her guidance, support, and assistance. First of all, let's check the application that I developed to comfortably display the results of model and the data samples. A few words about original data that was provided. It is separated into different TXT files or MATLAB, and every file it is the one sample of vibration, and also it is marked as a 0 and 1. Just for comfort, let's assume that 0 it is a normal vibration and 1 it is an anomaly vibration. Also, you can see the two different columns to match these different samples. And let's check the original data of the first and the 9th sample. And you can see that it's almost the same. It's like some vibration data with a lot of noises, and visually it is hard to understand what's the differences inside this vibration. But let's check the data after fast Fourier transform, and if we do it, we can see a lot of noises around the different peaks. Like here we can see two different peaks, and inside anomaly, it is the label 1, we can see different noises around a high peaks. That is a sign that we can specify these two vibrations in two different classes. Also, let's check 2D spectrogram. We can see the same noises also here around these two peaks, and it is not visible so much into the left side. So it is a good sign that we can specify it based on this data. Also, if we are using the 3D plot, it is much more visible that we have a lot of noises right here, and it is a bit different. Also, we have the same situation for other label 1 and label 0. And regularly, to solve this problem, scientists using the convolutional neural network or encoders, but CNN, for example, requires a lot of information about classes that we want to predict. And if we are talking about helicopters data, it is the problem to even collect the data when we have some abnormal operations. And in this case, we need to use something like a zero-shot learning, or closely to this concept, to specify and detect abnormal operations when we have a very few samples of abnormal operations or even don't have it. And how I realized my model: first of all, we are getting the fast Fourier transform from original data, and instead of using a 3D matrix, or in case of image, it's a two-dimensional matrix, plus we need to include RGB format. It's a more three-dimension, and it is a lot of data. Instead of all of this, I am just using an array or matrix with one row and multiple columns. We can name it into different ways. And after fast Fourier transform, we can use also convolution, but instead of using a neural networks after convolution, we can use some other techniques that I will show into the next steps. So to realize the convolution, we recursively apply a convolution of matrices to this array of data, and while the length of this array is more than 95, we are making convolutions with the kernel in 95 size. But after we are making convolutions with the kernel size S3, and as a result we can have a representation of all these vibration data just in a one vector in a three-dimensional space. Also, it is very easy to visualize this vector. We can see it, and we can see some interesting stuff. It is because of convolution that the x, y, and z coordinates is almost the same number, and we can use it in future. But just for now, we can transform our original data with fast Fourier transform and represent it as a three-dimensional vector. And of course, we need to check if we have some correlations for all provided vectors from the dataset. And yes, we have a very clear correlation, and we can see very clear two different clusters of data that was provided. In fact, all anomalies vectors located inside this distribution, and all normal with label 0 is located also in some distribution, and it is the clear distribution that is splitted with the big gap, and we can use it to specify our future vectors. And our model, as the next step, calculating the mean of these coordinates, because it's almost the same number after convolution, and we have just a one number to represent all the vibration sample, and by using it we can calculate a distributions. And from this moment we even don't need we realized from this moment, I mean, that we even don't need a data about some abnormal operations. We can have a data only about success operations of helicopters. We can collect this data, transform with the FFT, represent it with the convolutions as a vector. From vector we can create a point, and we can build a distribution. And from this distribution we can calculate the mean of this distribution. We can calculate a standard deviation of this distribution, and we can use just a simple statistical methods to set if a new data that will come to our model is inside this distribution, is inside a two sigmas, two standard deviations from left and for left and for right from the mean, and set it is abnormal or normal operation. We can calculate a z-score to say the probability of appearing of this vector, new vector, inside this distribution. So it's very flexible and easy to work and fast work with. So instead of using a big neural networks that is requiring different level of training, that is requiring a lot of data with abnormal operations, these techniques can calculate just the distributions of normal operation and check if normal vector is inside this distribution and how close this new data is to mean on 2 sigma, on 3 sigma, on 2.5 sigma from the mean, and it is very flexible. So here is just a small demo. Also about test train split, we are splitting our data as 80% for training and 20% for testing, and directly here you can see the train selection. So let's pick it, and let's check, for example, this type of vibration, and you can see the prediction from a model. Model said that anomaly is detected, and expected prediction is also anomaly. It means that right here our model is working correctly. Also we can see some different, for example, this sample, and also send a request to our backend and calculate all of this stuff and get the prediction. This prediction is also successfully anomaly not detected, and expected prediction is not anomaly. Also, the accuracy of the model after all the calculation is around 77%. If we are using a clear distribution with 2 sigma to left and right from the mean, it is around here. And also the model is support ranges. It means that we can pick some range of, for example, left side of distribution and cut everything from a left or cut everything from a right, or in a complex. By using these techniques, the accuracy was around 99%. Thanks for your attention, and I'm waiting for your question.